to the configuration part. Okay, let us move to the configuration part. Just a minute. Okay, so let me open Packet Tracer. Okay, so now let me take a switch. Let me take some devices. Take two devices, and now let me take a server, a dedicated server. Okay, so now what we are going to do, let's see how it works first with a dedicated server. How to activate DHCP with a dedicated server. Let me connect the devices. Okay, let's say that here the devices are in the network 192.168.1.0/24. Okay, so now after that, okay, so what I'm going to do, you see that right now the devices are this is my network. I have a dedicated server here, and I have two devices here. So I can go on PC0 here and go on desktop and go to IP configuration. You can see that right now this device do not have any IP address statically configured. So you can see I have static in order to configure an IP address statically, and I also have DHCP for what? For DHCP, so that this device can get an IP address automatically, and it is not checked. But if I want him to receive an IP address using the DHCP, I have to check this one like this, and then you see that they put what you're requesting for an IP address. Okay, but now, as I said, I was talking about the fact that if there is no, let's say that this is a DHCP server, this is the server that will play the role of a DHCP server, but right now I did not configure the server to play this role. Okay, so there is no DHCP server available yet. Okay, so now if I make this device to try to receive an IP address by checking the DHCP part here, you see that it is requesting for an IP address, but because there is no IP address, there is no DHCP server, no DHCP server will provide an IP address, and you see that automatically the server this device assign itself what? An IP address. Look, the IP address which is here start with, I don't know if you can see, but you can see that here this device assigned itself an IP address, and that IP address is what? 169.254.25.74, and this is what we call an APIPA address. So DHCP failed, and you can read here, DHCP failed, APIPA is being used. So an APIPA address is being used in this case when the device is not able to communicate or to receive an IP address from the DHCP server. Okay, and this is what I was saying. Okay, so now let me go back to static here. Okay, so now let me configure the dedicated server. So I will click on the dedicated server here. Okay, I will click on the dedicated server. So I will look for where in the menu here, I will look for services. I have services here. Click on services, and those are the services that are available to the server. Okay, and I will look for the DHCP service. The DHCP service is here, and I will click on DHCP service. Okay, so you can see that here it is put DHCP. This is the DHCP server. This is where I have to configure DHCP. You can see that the service is off. Okay, and I have to on it. Let me on the server, the DHCP, the service here. The service is now on. So the pool name. Okay, so this is the name. Here we can assign a name to our pool. Okay, our pool, and we have the default gateway. Okay, so now let me tell you that okay, when a DHCP server will not only the DHCP server will not only provide IP address okay, only one IP address, but the DHCP server will provide, okay, a bunch of information. So the DHCP server will provide an IP address, okay, you provide an IP address, and okay, no, let me put it this way. So the DHCP server will provide what we call IPv4 settings, okay, we call it IPv4 settings. Okay, so now in the IPv4 settings of that the DHCP server will provide, we have an IP address. We have an IP address that will be provided or offered by the server. We have what, the subnet mask. Okay, and among the IPv4 setting, we also have the default gateway IP address. The default gateway IP address, I mean the gateway, the IP address of the router that can help us to go out of our network. And the DHCP server can also provide the DNS server IP address. DNS server IP address. Okay, so those are the information that are provided by the DHCP server. So when the DHCP server is assigning an IP address, it's not only assigning that IP address, but is providing, let's say, other information as well. Okay, information like subnet mask, default gateway, and DNS server IP address. So when it comes to the DNS server IP address, this one, okay, DNS, we'll talk about it later on when we'll get there. Okay, so I wanted to precise it because you can see that here when configuring the DHCP server, you have to provide the default gateway IP address. Okay, so let's say that maybe the default gateway IP address in my case is the 192.168.1.254. So I have to provide the DNS server IP address. The DNS server IP address is 8.8.8.8. Okay, for okay, the 8, which is the IP address of the Google DNS server. Now here you can see they have written what, start IP address. So here, okay, I have to put the IP address from which the server will be start assigning or allocating IP address. So I will tell the server, okay, to start assigning IP address from the 192.168.192, okay, 192.168.168 168.1.1. Okay, so the server will start assigning IP address from this one, but not the subnet mask here is 255. Okay, 255.0, and then I have the maximum number of users, okay, that will be using devices and that need IP address. Let's say that maybe I want to assign 100 IP addresses, or I have 100 users that needs IP addresses. When it comes to the other information, you leave it like this by default. Okay, you don't touch it, and then you come here, you put save, you save your configuration. Okay, so now when you will save your configuration here, you can see that now down here we have our information that have been configured. So we have the pool name. The pool name is server pool. The default gateway is 192.168.1.254. The DNS server is 8.8.8.8. The start IP address is 192.168.1.1, meaning the server will start assigning IP addresses from this one. And then we have the subnet mask, which is this. We have the maximum number of users, which is 100. So all those information, those are the information that will be provided by the DHCP server. You understand? So now I told you that when configuring the DHCP server, you have to configure, assign the server itself. You have to assign it an IP address manually from the network here. Okay, so let's say that the server is in this network, and from this network I will take an IP address and assign it to the server. So I will go back to desktop here. I will go to IP configuration, and here I have to assign the server itself an IP address first for it to work efficiently. So I will assign the server the IP address 192.168.1. Okay, let me assign the server the IP address 192.168.1.1. Okay, and now I will go on the server. Okay, I will go on the server. I will go back to the service menu here, and instead of the server starting from 192.168.1.1, I will tell the server to start assigning IP address for the 192.168.1.2 here. So I'll remove .1, I'll put .2, because the .1 I've assigned it to the server itself. Okay, and I will save my configuration here. So you see it has changed. The router will start assigning from this IP address, but itself the server is using the IP address 192.168.1.1 and the subnet mask, which is here. Okay, so now if we were having a default router, so the default gateway will be 192.168.1.254. Okay, and then what I'm going to do after doing all this, and I configured my DHCP server, the service is on. The only thing that I have to do is to get out and go to the device and try to see if they can receive IP address from the DHCP server. So let me go on PC0. I will go on IP configuration, and I will now check the DHCP here. But you can see that now DHCP request successful. DHCP request successful, and the IP address that the device got is what? 192.168.1.2. Okay, 192.168.1.2, and the subnet mask is 255.255.255.0. The default gateway IP address is 192.168.1.254, and the DNS server is 8.8.8.8. And this device was able to successfully receive an IP address from the DHCP server. So now I will go to the PC1 here and try to see if PC1 can also get an IP address automatically from the DHCP server. I will check DHCP here, and yes, PCB was able to get an IP address that automatically from the DHCP server. Okay, so now you can see it, how it works. So now everything is working fine with the DHCP, with the dedicated server case. So if, for instance, I'm adding a new device in the network. Okay, let's say that I want to add a new device here. Okay, maybe say PC2. I want to add a new device in the network. I want to connect it to the network. Okay, so now what we are going to do is to try to look at those messages that I was telling you, the discover message, and the offer and everything. So now let me go to the simulation mode here. Let me activate the simulation mode so that we can see those messages. Okay, so that we can see those messages. I will go on the simulation mode here. Okay, I will click on show all known, and I would click, then after that I will click on edit filters, and now I will look for the DHCP protocol. You can see DHCP here. You check it. Okay, after checking DHCP, and then you exit, so when checking DHCP here, you want to see DHCP messages, and you can exit here. Okay, so now you go on, I will go on the device. Okay, now what I'm going to do, I will go on the device PC2 here. Okay, then I will go to desktop, and I will go on IP configuration. I will check DHCP here, and automatically you can see that a message have been generated, and that message here you can see is what is it, which type. If you bring your cursor on the message here, you over the cursor on the message here, you can see that the type is what? DHCP. Okay, if you click on the message, we can look at the information that are contained in the message. So you can see that when it comes here, here you can see what the DHCP client construct a discover packet and send it out. A discover packet and send it out. A discover packet and send it out. But now look at the outer layers information here. We have layer 7. I told you that DHCP is a layer 7 protocol, and look at the information that are here. Look at the layer 4 information. Okay, we have what? UDP source port 68. I told you that, and UDP destination port 67. We have the layer 3 information. The layer 3 information is where we have what? IP address information. So the source IP used by this device here, okay, is what? 0.0.0, meaning that it does not have an IP address yet. And the destination IP address is what? 255.255.255.255, as I told you. And then we have what? Okay, we have the layer 2 information here. This is where we have MAC address information. So we have the source MAC address, which is the MAC address of the PC, but the destination is the broadcast MAC address. Okay, so you can also click on the outbound PDU here to look at those information. Okay, you can increase here. We have the Ethernet information here. We have the destination IP address, destination MAC address FFFF. We have the source MAC address, which is the MAC address of the PC. We have the source IP, look, 0.0.0.0, the destination IP, which is 255.255.255. So we have the source port, which is 68 for the client and 67 for the server. Okay, but we also have another information that we call the client hardware address, which is the MAC address of the DHCP client. Okay, and this is basically what I was saying. So this is a discover message, and you can see that this discover message will be sent to the switch, and it's a broadcast, meaning that it will be sent to all the devices in this network. So all the devices will receive this message, but not all of them will process it. You can see that now only PC, the server is processing what the message, but the other one, what they put a cross on it, meaning that they discard the message, they will not process it. And then the server will answer here, okay, with a message, and that message also is what is a DHCP message. So now if I click on that message, okay, you can see that let me go on the inbound PDU here, the inbound PDU, okay. You can see that now the inbound PDU, you can see that now still the destination MAC address is what to still broadcast, but the destination IP address is still also broadcast, but now it is the server which is responding. So meaning that the server will put as a source IP its own IP address, the one that are configured statically on the server, okay. But now if I go down, you can see that here I have what the DHCP information that are here, okay. So here when it comes to the DHCP information, I have the client address, okay, the IP address used by the client, okay, which is the 0.0.0, meaning it does not have an IP address. And then I have your client address. Your client address is the address that the server is proposing to that device which is requesting one. You understand? So your client address here is the IP address that the server is proposing to that device which is requesting one. You understand? Okay, and you can see that there is not only this information that the router is the server is providing, but we have other information like the domain name server, which is 8.8.8, okay, and you can see it here. Okay, so now when I will exit here, if I press play here, you see that that message, the offer message, is also broadcast. It was sent to all the devices here, but PC0 and PC1 did not process it. Only PC2 processed the message. And now if I press place again, PC2 is going to respond with another message, which in our case what the request message. So the request message is also broadcast, sent to everyone, okay. The server now will answer with what the acknowledge message, okay, and the acknowledge message will be sent also to everyone because it is also a broadcast. And now the process is complete. After that, the process is complete, okay, the device here, as I said, okay, will now, okay, let me go on in the real-time mode. Let me go back in the real-time mode. If I go now on PC2, you can see that PC2, it said what DHCP request successful. PC2 was able to get an IP address which is the 192.168.1.4. Are we okay? Okay, so this is how DHCP works. Okay, this is how DHCP works with a dedicated server. So now let's now look at the case where we will configure the router. Let's configure the router to be the DHCP server. So what I'm going to do, let me remove the dedicated server here. Okay, let me remove the dedicated server here, and I will go on each device and put them back to static. Okay, so now what I'm going to do, let me add a router. Let me connect the router. Okay, so now what we are going to do, let us configure the router as a DHCP server. So what I'm going to do, let me connect to the router, go to the CLI of the router. No, let me move to the global mode of configuration, enable config enable config G for configure terminal. So as I said, this router will play the role of the DHCP server, but I have to configure this interface of the router so that it can be, so that I have to tell the router that this interface belongs to this network, and on this interface of the router I will configure the IP address. This interface of the router, I will configure the IP address 192.168.1.1/24. Okay, this is the IP address I will configure on the router. Okay, so I will go to the router here, go under the interface, I'll go under the interface Giga Ethernet 0/0, and I'll configure the IP address 192.168.1.1 255.255.255.0 press enter, and I'll activate the interface by inputting the command no shutdown, and the interface is now activated. And if I want to check my configuration, I can use the command do show IP interface brief to see the resume of the available interfaces and the IP address configured on them. You can see that on the Giga Ethernet 0/0, I have the IP address 192.168.1.1, which is configured. Okay, so now I configure an IP address on this interface. The router now knows that, okay, this network is connected to me. Okay, because how the router knows that, because now based on that IP address, if you check the routing table of the router using the command do show IP router, you can see that in the routing table of router 1, he said what, I know this network which is directly connected to my interface Giga Ethernet 0/0. Okay, so now how to configure the router as a DHCP router, as a DHCP server. Okay, so now I should make use of the command at the global mode of configuration. I have to configure first the pool, what we call the pool name. I have to configure the pool using the command IP space DHCP pool. Okay, and if I input the question mark, you can see that the next thing that I have to configure is a word, and that word is what we call the pool name. Let's say that I will configure IP DHCP pool. The pool name that I will put here, let me put that it is the network. Okay, let me put network 192, for instance. Okay, hyphen 192, and this is my pool name. I'll press enter. But now I'm under the DHCP sub mode of configuration. Okay, so now after configuring this, I have to enter the command network. I have to preset the network from that will be considered as my pool of IP addresses. So the network here is 192.168.1.0, and I have to preset the subnet mask 255.255.255.0. So after configuring this, I have just have to put what, to press enter. So now I have to precise. You remember that with the dedicated server, I configured with the default gateway, but here I also have to configure the default gateway IP address. But here I will use the command default router, the default router 192.168.1.254. So the default router command in this case will define the default gateway IP address that will be provided to the devices. Okay, so now you press, when configuring this, you press enter. Now you can also configure what, the DNS IP address using the command DNS server, and you put the IP address of the server, which is 8.8.8.8, and you press enter. Okay, so you can also configure what we call the domain name using the command domain name, and you put, for instance, that the domain name here is maybe cisco.com, for instance. Okay, so now after configuring all this, what you can do, you can exit. Okay, you can exit, and now you can you can check your configuration using the command do show, okay, IP DHCP pool. Okay, to check the pool that you configure, do show IP DHCP pool. So now you can see that my pool name is one network 192. Okay, I have what, a total number of address of 254. Okay, I have currently one subnet in the pool. Okay, I have IP addresses from 192.168.1.1 out to 192.168.1.254. So those are the IP addresses that can, here I don't have any IP address that which is leased yet. Okay, so now you can see total addresses, total number of address, so the total number of addresses, the IP address that have been leased. Okay, so now I also have excluded IP address. So now you know that in this network, the 192.168.1.0/24, there is already one IP address that I have assigned manually on this interface of the router. So I don't want the router to assign that IP address again to a device. Okay, so in order to let the router know that, okay, this IP address is already used and you don't have to assign it again to a specific device, you have to exclude that IP address. But now that command that will help you to exclude that IP address from the pool, you have to input it at the global mode of configuration using the command IP DHCP excluded address, and you put the address that you want to exclude. For instance, 192.168.1.1. This is the IP address that I want to exclude because I already configured it on the interface of the router. You understand? And then you press enter. When you press enter, you can check your pool again. Okay, so now you know that it's not compulsory to enter for you to enter the command again and again. You can just recall the command by using the up arrow. If you use the up arrow, you can recall commands that you just recently entered. Okay, so now I need this command. I was able to recall it. I can just press enter automatically. So now you can see that now among the total number of address, I have 254, but now I have excluded address. I have one IP address that have been excluded from the pool. Are we okay? So now that my my DHCP, okay, so you can also check your configuration with the do show IP DHCP DHCP no do show IP DHCP pool. Okay, I already use this command. Okay, yes, this is the command, but you can also, if I go on the global, the privilege mode of configuration, you can use this way, show IP, okay, show IP DHCP, or show IP DHCP question mark. Okay, you all have, okay, show IP DHCP binding. Okay, you can look at the binding table. So the binding table here is the table that tells you that, okay, those are the list of IP addresses that are currently listed to the device, to the host in the network. And you can see that right now there is no IP address list. So now what I'm going to do, let me go on PC0 here and try to get an IP address automatically. Go on PC0, desktop, DHCP. You can see that the PC0 was able to get an IP address automatically from the DHCP server. So it's working fine. But now if I go back on the router and I use that command again, the DHCP, so show DHCP, show IP DHCP binding, press enter, you can see that right now in the binding, the DHCP binding table, I have some information. So the DHCP binding table is telling me that right now I list this IP address, the 192.168.1.2, and to this device which is using this IP address, and the lease expiration is not mentioned, but this IP address was the device got this IP address automatically. Okay, so right now we have one IP address which is leased by the server. So now if I go on the router and use the other command, show IP DHCP pool, press enter, you can see that even using this command, I have the information which is telling me that they have one IP address which is leased, and I have also those information down here. Okay, so list 1, excluded 1, I have a total of 254. So now I can go on PC1 here. Okay, DHCP, correct, I have a second IP address which is leased. If I go on PC2 here, DHCP, I have a third IP address which is what? Which is also leased by the server. So if I go on the router here and I check again those commands, show IP DHCP pool, okay, you can see that now I have what? I have a leased IP address is 3. I have one IP address which is excluded, and I have a total IP address of 254. Okay, so now this is how we configure DHCP with a Cisco router. Okay, this is how we configure an IP DHCP with a Cisco router. Okay, so now let's say that okay, yeah, Olufemi, you have a question? Go ahead.
Sorry, please, if I want to save it on the router, probably I've made a configuration and I want to save it. How do I save it?
Come again?
Then if I want to save my configuration on the router, how do I save it? If I want to continue after I save it, how do I open it back?
Oh, sorry, I will not come back to this again. Those are basic things that we started with when we started the training. Okay, the videos are there.
No, I was not part of the training at the beginning. I joined probably after some weeks.
Yeah, but you can rewatch the videos. The videos are available in the drive for you to rewatch. Okay, because
Okay.
yeah, the videos are there, the videos are available in the drive. But anyway, so if you want to save your configuration right now, you just have to use the command. For instance, do write memory at the privilege mode of configuration. You use the command write memory. Okay, it will save your configuration, but you can use the abbreviated way, which is WR. You can use WR, you press enter, it will also save your configuration. But this is only one way of saving the configuration, but we have many ways that you can use. We have 2 or 3 like this. So just go on the drive, look for the basic configuration video topic, the basic configuration video topic, and then you rewatch it. All the information are there, please. Okay, so now we have seen how to configure, how to make the what, this router as what, as a DHCP server. Okay, okay, so now what we are going to do, okay, so we are going to do the case where the DHCP server is located in another network, because so far we have been working configuring DHCP server with the host in the same network. So now if we have the case where the DHCP server is not in the same network as what, as the host, what should I do? We have to configure, we have to make the router to behave as the DHCP relay agent. This is what I told you. So now let me use this case. Let's say that, for instance, I have another router. Okay, let's say that, for instance, I have another router here. Okay, so basically what I'm going to do, okay, I will not, what I'm going to do, I will not do the DHCP configuration again. So what I'm going to do, let me take this router. Okay, let me take this router, which is here, we consider the DHCP server. So I already configured DHCP. I already have DHCP configuration on this server, on this router. But at this router, I will not. I will move it. I will put it here, and I will take this one. This router, I will put it here. So now I will connect the new router to the switch here. Connect the new router to the switch here, and connect the new router to the DHCP server here. So now here we have the network 192.168.1.0, and here we have the network let's say we have the network 10.0.0.0/30. Okay, so now what I'm going to do, I have to configure IP addresses on the routers here based on the network scheme here. So on this interface of the router, of router 1 here, on the interface you get an 0/0, I have to configure this IP address, the 192.168.1.1. So I'll go on router 1 here. Okay, I'll go on router 1 here. No, I'll go under the interface Gigate Ethernet 0/0. I'll configure the IP address 192.168.1.1 255.255.255.0, and I will now shout the interface. The interface is activated. So I'll go on the interface of the other interface, the interface Gigate Ethernet 0/1 here. Interface Gigate Ethernet 0/1, and I'll configure I will configure the IP address. So here I will configure the .1 of this network, of the 10 network, the .1, and the other router here I'll configure the .2. So here I'll configure the .1, here I'll put the .2. So on this interface I'll configure the IP address 10.0.0.1 255.255.255.252. This is the correct subnet mask for the /30. Press enter, and I'll activate the interface with no shot. Okay, so now what I'm going to do, let me go on this interface of the DHCP server here. So the enable conft interface Gigate Ethernet is 0/0/0, I think, here, this interface here, and I will configure the IP address 10.0.0.2 255.255.255.252, and I'll press enter, activate the interface, and I'm okay. And I can check with the command do show IP interface brief. press enter, and you can see that my IP address is well configured on this interface of the router. So let me call this one, okay, this router, let me give in the name host name router 1, okay, and the other one, let me give it the name host name router 2. Okay, so now what I'm going to do, let me check the interface IP address configured on the interface of this router. Do show IP interface brief. My IP address are well configured on those interfaces without problem. So now let me go on the devices and put them back on static mode, static here. Okay, so now if I go on the router 1 and I check his routing table using the command do show IP router, you can see that router 1 knows two different networks that are directly connected to it, the network 10 and the network 192, and this is normal based on what I taught you. So if I go on router 2 here and I check his routing table, you can see that router 2 only knows one network, which is the network 192, the network 10, and the network 10 is directly connected to router 2 through the Zigate Ethernet 0/0 here. You understand? So router 2 is not aware of the network 192 here. So if router 2 wants to join this network, it will not be able to do that. So what we can do, we can teach router 2 using static route how to join this network here. So I can go on router 2 here and configure static route IP route 192.168.1.0 255.255.255.0, and the next IP address, I will use the IP address on this interface of router 1, okay, which is 10.0.0.1. So I will use 10.0.0.1.1 and I will press enter. So now I will check my routing table again, do show IP router, and you can see that now I have a static route going to that's the remote network, but I have to send my traffic to the next IP address 10.0.0.1, which is the IP address configured on router 1 here. Are you okay? So now here, okay, the network is well configured and the static route also, they are well configured. So now you see that the DHCP server is beyond the router 1. Okay, and I told you that basically what will happen here, those devices here, okay, if PC2 here needs an IP address, I'll activate DHCP here, it will send a discover message. The discover message will make it to the switch will send it to everyone, and it will also send it to the router like this. But when the router will receive it on this interface, because it's a discover message, and this router is not to the DHCP server, the router will see that broadcast message as a normal broadcast message, and it will do it, it will drop it or discard that message, and that message will never make it to the real DHCP server, which is beyond here. You understand? So the DHCP server will never receive the discover message and will not be able to answer to what? To the discover message sent by those devices. Don't forget that we already configured the DHCP on this router which is here. Okay, this router is already configured as a DHCP server. Okay, so now if I want the router 1 here to take those messages and send it to the DHCP server, I have to make the router 1 to play the role of the DHCP relay agent. The DHCP relay agent. So the DHCP relay agent. But how to make the router to play the DHCP relay agent? So you have to go to that interface of the router, of that router that you want to make you want to make him the DHCP relay agent. You go on the interface that is receiving those broadcast messages. If PC2 sends a broadcast discover message, PC0 sends a discover message, PC1 sends a discover message to get an IP address, those discover messages will be received by this interface of the router. You understand? So now you go on this interface of the router, and then you configured under this interface, you configure the command IP helper address, and you put the IP address of the server. Right now the server has one IP address on this interface, so this interface has an IP address 10.0.0.2, so I will put the IP address 10.0.0.2 as the IP. I will use it as the IP address of the server. So you configure this IP address under the interface, okay, on the interface which is receiving discover messages coming from the host. How are you okay? I hope this is clear. Okay, so now what I'm going to do, let me go on that router let me go on router 1. So okay, no, let me show you that right now they can't receive an IP address. Let me go on simulation mode, show unknown, edit filter, check, let me check DHCP here, check DHCP, let me exit. But now if PC2 tries to receive an IP address to DHCP, it will generate a message. But look, this message will go to the switch. It's a broadcast message sent to everyone. The router 1 will receive it, but now all of them, router 1 will broadcast, drop the message. That's why he's putting a cross. Understand? That's why he's putting the cross. So each time the device will send a message, and that message is a broadcast message, the router is not going to process it. It's going to drop it because it's a broadcast message, as I said. But we don't want the router to do that. Now I will configure what I said, this I command on this interface of the router, and the router will not take that broadcast message and convert it into a unicast and send it to the DHCP server here. Understand? So now what I'm going to do, let me go, let me reset the simulation. So let me go on router 1 here, on router 1. Okay, let me go on router 1. So now let me go under that interface which is receiving those broadcast messages, which is the interface Giga Ethernet 0/0. And I told you that here I have to configure the command IP helper. So IP helper address, the command is there, and I'll put the IP address of the server, which is 10.0.0.2, and I'll press enter. Okay, so now I can check my running configuration file with the command do show run. Okay, if I go down, you can see that under the interface Giga Ethernet 0/0, I have what, my IP address which is configured, but I also have my IP helper address which is present. Okay, so now if I try, my IP helper address is there present under this interface. So now if I try, PC2 try again to receive an IP address through DHCP. Okay, you can see that. Okay, let me go, let me reset the simulation. Let me go on PC2. Okay, let me go on IP configuration. Let me check DHCP. A message is generated, but now when the message will be sent to the DHCP server, the DHCP server now will be able to take that message and convert it into a unicast. Okay, you see the DHCP server is not dropping the message anymore. There is no cross, and the message is sent to the DHCP server. Okay, the DHCP server will process the message and will answer. Okay, and the message will get back to the device here, and this is how it will work. Okay, so they will go through. So now even if the router is in another network, right now the DHCP server is in the network 10. Okay, and the hosts are in the network 192, but still using the IP helper command they are able to communicate. Okay, let me go back in the real-time mode. And you can see that right now if I go on PC2, you see that PC2 was able to receive what, an IP address. If let me use PC0, you can see that PC0 also is receiving an IP address. DHCP request successful. If I go on PC1 also is able to receive an IP address. You can see DHCP request successful. Okay, so this is how DHCP works, and I think we will stop here for today. Okay, do you have any questions so far? Do you have any question? So if there's no question, we'll stop here from today. Okay, so basically we have done with DHCP. So we saw almost everything concerning the main information concerning DHCP. So now what I'm going to do, I will send the lab I will upload the lab in the drive. I will also send it in the group, so that you will be working on the technology that we saw so far. Okay, so I will send you a lab. Maybe on that lab we have basic configuration, static route, and now I will add DHCP. As I said, we are moving on, so and more technology is coming, so we'll be having labs with more technology, so you have to take your time to refresh yourself about everything that we saw. Okay, everything that we saw, we watch the video and practice. I'll send the lab, I'll upload the lab in the drive, and I'll also send it in the WhatsApp group. Yeah, Olufemi.
Sorry, is it possible we have static and DHP configured on a system at the time?
Static, static DHCP. What is static DHCP?
I mean, is it possible, under the configuration we have static, we have DHCP. Is it possible the two are configured at the time?
How the two is configured at the time? It's not possible. It's either you get the IP address through static way or the dynamic way. It's not as how are you going to? So you want to activate both at the same time to obtain one thing? It's not possible.
Okay, thank you.
Okay, but now maybe you are thinking about this. There is this case. Okay, the laptops, as I said in the beginning when we started the training, laptops, okay, computers, desktop routers, they only have one network interface card, one what we call the NIC, one network interface card, and that network interface card can only have one IP address. You understand? But now we have servers. Servers are also computers, but servers, they have the capability or the possibility to have many network interface cards. So you can have one, maybe let's say that one, two, three network interface card on the server, meaning that on that network interface card here you can configure statically an IP address, but on the second network interface card here you can activate DHCP. You understand? On the third one here you can assign also statically an IP address. Okay, so this on the server. The server has the possibility to have many network interface cards. Okay, the first one can also receive an IP address that you can configure statically. The second one you can configure dynamically. But on your laptop, your personal laptop that you are using, okay, there is no way for that network interface card to receive at the same time an IP address. You configure an IP address statically, and then you configure a second one that you will use. So it's like that same network interface card will have two IP addresses at the same time. This is not possible. Okay, so if there's no question, okay, I think we are done with our session. So I hope you guys, I hope the session was really informative, and then you have been able to learn something new today. Okay, so see you next time. See, okay, 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 let me inform you. Okay, wait just a minute, just a minute.